Right, so in this section we're looking at circles, angles, and angular movements, right? So this is the technical maths textbook, grade 11. So it's the exact same contents, just using the grade 11 book. So you need to read up in the book parts of a circle for exams, circular measurements, converting angle, measure, length of the circle arc, and all that stuff. Right, so remember we learned all of this in grade 11. I hope you kept your grade 11 book. So I'm going to look at this topic here. Angular and circumferential velocity. Now this is page 166. So if you go to page 166, read the textbook so you can understand. That's angular and circumferential velocity. Right, so they're talking about a point on a circle can be measured using angular velocity. Right, it's also known as linear velocity. When we calculate angular velocity, we assume that the object is moving along a circular path. So if you have a circle, this is on the outside of the circle where this point is moving. Okay, angular velocity, right, so it goes as omega, can be determined by multiplying the radians in one revolution by 2 pi with the revolutions per second, right? So this is how we get the formula of, I just call it W, right? But it's actually omega. So W is equal to 2 pi n. So the angular velocity, that's the W. Okay, that's that one. That's the angular velocity. So if you're calculating the angular velocity, you are going to use this formula. So I'm going to call it W. W equals to 2 pi n, right? So notice that it says with respect to time. Now remember that n can be in different times. It can be in per hour, per minute, per second. So there's going to be what we call conversions. Right, so you have to know your conversions here to work with this section. So circumferential velocity is the linear velocity on the point of a circumference, right? Thus we say V is equal to pi times diameter times n. So this is, in other words, speed. Okay, so we can calculate that little v means speed. So if you want to calculate the speed of a point on this circumference, then it's going to be pi times d, which is the circumference, multiplied by n, which is the rotational frequency. Right, so n is the rotational frequency. Another question they can ask you is calculate the rotational frequency. This means you'll have to make n subject to the formula, and you'll have to say n is equal to v divided by pi d. And in this way, you will use the speed that they gave you, and this is how you will calculate the rotational frequency, which is going to be n. So the relationship between angular velocity and circumferential velocity is given below, right? So we got W is equal to 2 pi n, and we can calculate n like that. Okay, so that's the formula for calculating n. Right, I hope this is big enough on the screen. So equating these two, you can get now this formula, right? So velocity is also equal to W times R. Okay, do you see it? So there's your formulas you're going to use. The unit for measuring linear velocity is meters per second. So notice that the speed there is meters per second. Right, and it takes you right back to the same velocity that's there. Hope that makes sense. Right, so let's look at some of these worked examples. Right, looking at this worked example here on the left, the Earth rotates on its own axis once every 24 hours. Calculate the Earth's angular velocity of rotation in degrees per hour. So the complete circle, we know for full rotation it is 2 pi radians. Therefore the angular velocity of the Earth's rotation equals to, so 2 pi, right? So 2 times pi divided by 24, right? That's exactly radians. So that means if you take the 2 pi divided by 24, our answer will be in radians. Okay. Now, if we take that answer and we multiply it by 180 over pi, remember when we times something by 180 over pi, we convert it into degrees. So this means that the Earth is rotating at 15 degrees per hour. Okay, it's that simple. But I'm going to go straight to a past paper, and this will help you for the exams rather. But before that, here's a simple example to understand.
Calculating the average angular velocity. A small electric fan makes 240 revolutions a minute. What is its angular velocity in radians per second? Okay, so for one full rotation, that is 2 pi radians. Okay, radians is in 2 pi. So one full rotation is 2 pi radians. Now, for this fan does 240 revolutions per minute for 1 minute, and that's 240 revs in 60 seconds. That gives us a total of 4 revs per second. Now, 4 revs per second times 2 pi radians gives us a total of 8 pi radians per second. Or, if we were to simplify that, it'd be 25 radians per second. These being our final answer.
Right, so in this paper too, there's a question 10 dealing with circles and speeds and rotational velocities. Okay, so all you have to do is work through what I've given you here and you'll be okay. Right, so the question says, a fan has a diameter of 300 centimeters. It has a circumferential velocity of 500 meters per second. The first question says convert 500 meters per second to kilometers per hour. The first thing to look at is 500 meters per second. What does this mean? This means 500 meters are covered in 1 second. Therefore, 500 meters per second is speed. Now, this means we have 500 meters. Notice the question wants kilometers. So let's work on the meters first and convert it to kilometers. When you go to the bigger unit, you divide. So there are 500 meters divided by 1000 because there's 1000 meters in a kilometer. The K means 1000. So this means we are going to divide. We are going to a bigger unit. Meters is smaller than kilometers. So dividing it, we will get 0.5 kilometers in 1 second. Now you have to ask yourself, how many seconds in an hour? It's 3,600 seconds in an hour. There are 60 seconds in 1 minute. Ask yourself, how many seconds are there in 60 minutes? Because 60 minutes is 1 hour. So 60 times 60 is 3,600 seconds in an hour. So the easiest way to calculate this would be to cross multiply. Punching that into your calculator, you should get exactly half of 3,600. 1,800 is your answer. Right, and that will be kilometers per hour. Don't forget to include the units. So just to convert this, there's 2 marks. So first step, you have to divide, right? You have to divide, yeah, by 1000 to convert it into kilometers. Next, you're going to multiply by 3,600. As simple as that. Right, the second question says, determine the rotational frequency of the fan or the wheel, right? So why do they say a wheel? Because there's an outer circle that the fan forms when it is rotating. Okay, and so the fan, as it rotates, it forms a circle. Right, so here they want us to find the rotational frequency, and that is noted as N. Now the formula is velocity is equal to pi times diameter times N. We have to make N the subject of the formula. How will we do this? We'll say V divided by pi divided by D. This means N will be left. So N will be subject of the formula. Notice that the opposite of times is divide. So when we take pi and D over to the other side, it will become V divided by pi D. So now what is the velocity? Do you see it? Don't forget that velocity is speed. When you are driving your car, it is in kilometers per hour. So it is speed. Right, remember that the diameter was 300 in question 1. So 300 centimeters. So you have to ask yourself the question, can you substitute 300 here? Ask yourself that question. Do note that the speed was in kilometers per hour. The diameter is in centimeters. What does this mean? This means I'll have to convert that diameter in centimeters to kilometers. Now, how many centimeters are there in a meter? There's 100. So 300 divided by 100 will now give me meters. Now I have to take my 3 meters and convert it to kilometers. How many meters are there in a kilometer? Remember, the kilo means 1,000. So this would mean I will have to divide it by 1,000. On your calculator, 0,003. So on your calculator, it'll be 1,800 divided by pi divided by 0,003. Or you can use brackets in the denominator. So 1,800 divided by, open brackets, all that's in the denominator, close brackets. And that's the answer we get. Right, now you have to work out what the unit's gonna be, right? So the rotational frequency is in revs. It can be revs per second, revs per minute, revs per hour. What will it be in this case? So because we were using hours and kilometers, you get the idea. It's going to be kilometers per hour was our speed, so therefore it's going to be revs per hour. Number 3's question, determine the angular velocity of the fan/wheel in radians per second. So when we're saying fan/wheel, we're talking about the circumference of the fan as it's spinning. Right, so here we have 2 times pi. Right, so that's our formula. So it looks like W is equal to 2 pi N. Notice that's all multiplication. That's the angular velocity. So we have to convert that little n into something that's going to work with seconds. Now notice that our answer there, number 2, right at the bottom of the screen, our answer was in per hours. This means we're going to have to make it into per second. So we're going to have to take our revs per hour and convert it to per second. Now notice that rev amount is a big number because why? These are the revs that happen in 1 hour. Now we need to know how many in a second, just 1 second. So obviously that big number is going to become a smaller number. So this would mean we'd have to divide that by 3,600. And then you can plug that all into your calculator and get your answer. Right, the next question says determine the distance a point will cover that is on the fan's circumference. Right, so we're talking about on the fan circumference, right, in 15 seconds. Now notice we have the speed in number 1 and we have seconds. Now notice in the first number 1's answer it was in kilometers per hour, and here they are now talking seconds. This means you're going to have to convert the kilometers per hour to kilometers per second. So how will you convert that? Will you divide or multiply? Now remember, this is 1,800 kilometers traveled in just 1 hour. Now we want to know how many kilometers will be traveled in just 1 second. Don't you think that's going to be a very small number? Therefore, I should divide by 3,600 because there are 3,000 seconds in 1 hour. Okay, so we get 0.5 kilometers per second. Right, so here it goes right back to physics grade 9, distance, speed and time questions. Don't forget to use the triangle on the top left. Distance, speed. Distance is equal to speed times time, the triangle. So here we want the distance. So distance is definitely going to be speed times time. If you wanted the speed, then speed will be distance divided by time. If you wanted the time, then time will be distance over speed. So we're looking at the triangle on the left. So the speed is 0.5 kilometers and the time is 15 seconds. Put it into a calculator. Right, we get the answer 7.5 kilometers. Right, so after 15 seconds, that fan has traveled 7.5 kilometers. That is, the point on the fan has traveled 7.5 kilometers. The next question says, how long will it take the fan to make a half revolution? Now looking at N is in revs per hour. So what was our N in revs per hour? Right, that was our answer in revs per hour. So we want to know per second. We will have to divide it by 3,600. So notice now we have 53.05 revs in just 1 second. The question says, how long will it take? They're asking how many seconds. Okay, how long will it take to make only a half a revolution? So here we got 53.05 revolutions in 1 second. So we know that it's 53.05 in 1 second. That means revs per second. And 0.5 revs. Okay, so that's a half. The question says, how long will it take? That means X. How long? X seconds. We don't know how many seconds. It'll take to make a half a revolution. How many revolutions? 0.5. Cross multiply because it's directly proportional and solve for X. Right? Next thing, divide both sides by 53.05. And so now we get 0.0, so 0.009 seconds. Right, and this is how you do this section.